Okay, we're going to get our last major rule as far as differentiation. And the last major rule is it implies at the top there, the chain rule. So a little algebra review first. Let's have two functions here. Let's let f of x equal x to the ninth and g of x equal 2x plus 5, and then find f of g of x. So now let's recall this is composition. That little circle means composition. That is composition. And composition is the idea of putting one function inside another. So f of g of x, written that way with the little circle, is the same thing with the functions nested, one inside of the other. And then what this particular problem has asked us to do is to find the rule, find the formula that represents f of g of x. So we start on the inside and replace whatever's on the inside, g of x this time, with its rule, which is 2x plus 5. Then we apply f's rule, replacing the x with whatever I have in parentheses, in this case 2x plus 5, and I get 2x plus 5 in the ninth. So there is the composition f of g. And what we really want to point out here is down here. So we see, if we call it h of x now, we see that h of x equal to x plus 5 is the result of composing f of x equal x to the ninth and g of x equal 2x plus 5. That is a composition. And then we got that by putting g of x inside f of x. And that's how we're going to recognize these things of compositions, is when we see something inside another, inside and outside functions. And so for the guy that we have here, 2x plus 5 to the ninth, we would say that the g of x, 2x plus 5 is the inside function, and g of x, or f of x equal x to the ninth is the outside function. So two new functions, do it again. And so f of g of x, written that way, is the same thing as it's nested together. And again, we'll start on the inside, replace g of x with its rule, 3x in this case, then use f's rule, which is sine x, but when I get to the x, I replace the x with whatever I have in parentheses, sine 3x, or you could write it this way with parentheses. Sometimes the arguments will be in parentheses, sometimes not. It just depends on the author and the textbook and whatnot. Those mean the same thing. Now, if the argument ever involves something other than multiplication or division, say that was 3x plus 5, then the argument definitely would be in parentheses. But my point to doing this one is that this is a composition. 3x is inside the sine function, that this is a composition. The above is a composition. It is not a product. It is not sin times 3x. A trig function and its argument is never a product. It's never tan times x, cos times x. You can always think of trig functions and their arguments as compositions, with the argument, the angle, being inside the trig function. They are never products. I'll have many students differentiate this as a product, and it is not a product, and you just lose all the points. It's a composition. Now, something we want to note here, very, very importantly, sine 3x is not 3 equals sine x. You can never, quote unquote, factor term out of the argument the angle of a trig function. You can't. It's just not true. And you can think of a simple example of why it's not true. Consider, say, sine of 3 pi over 2. We all should know that sine of 3 pi over 2 is -1. It's certainly not what you get if you say factor out that the 3 over 2, which would give me 3 times 2 times 0, which is 0. That's just completely and totally, absolutely bogus wrong. You can't factor out from the argument of a trig function. And if I see that, lots and lots of points taken away. You cannot do that. It's just wrong. And then I kind of alluded to this before about the arguments of trig functions changing. I said before that the arguments, your angles of your trig functions, are not going to change unless you did some trigonometry on them. Unless you did a double angle formula, a half angle formula, angle addition, angle sum. There are trig identities that change arguments. There are trig identities that change angles. But calculus and algebra will never change your trig arguments, will never change your trig angles. So as soon as you see that that angle, that argument is different, unless you did some trigonometry to it, you have made a major mistake. Okay, so I've probably beaten that horse to death enough. So my point on this first page here is composition, the idea of inside and outside functions. We don't know how to differentiate those yet, so that's what we want to get to. How are we going to differentiate compositions? And we're going to differentiate compositions with our last rule, the chain rule. And so there it is, the chain rule in symbols, the derivative f of g of x. Notice composition, g inside of f, is f prime of g of x times g prime of x. I'm not sure I said that right, so I'll say it again. F prime of g of x times g prime of x. In words, to differentiate a composition, take the derivative of the outside function, evaluate at the plane inside function, times the derivative of the inside of function, and of course you need to memorize this. You've got to know the chain rule. And so now we are just going to start practicing. Practice, practice, practice. And so, showing more detail than I'd expect of you, first we're going to identify it as a composition, inside and outside functions. And so I've got an inside function of 2x plus 5 and an outside function of an exponent of 9. So when I go to do the chain rule, when I go to differentiate, I start on the outside, and I do what I'm supposed to do for an exponent when I differentiate. When I differentiate an exponent, I multiply by the exponent, decrease the exponent by 1, leaving the middle alone for now. And so I'll write down my first part of the words, which is derivative outside. So I did take the derivative, what you're supposed to do for an exponent of 9. But now the rest of the words say, take the derivative of the outside function, evaluated at the plane inside. If you don't like the phrase evaluated at, try this. Plug in plane inside. And so what goes in these parentheses is 2x plus 5. And there's the first part of the chain rule. But there's two parts. It goes in, two parts connected together like a chain, thus the chain rule. So then the second part, so we have the derivative of the outside function evaluated at the plane inside function. We did that. And then in symbols, I'm going to take it in 2 steps, times the derivative of the inside. You're not going to have to show that step. That's me just being very, very explicit. And now let's finish it up. So it's 9 times 2x plus 5 to the 8th times 2, derivative of the inside, 2, for a final answer of 18 times 2x plus 5 to the 8th. And that is completely and totally and fully simplified. There is not anything you can do easily after that. Now, some people are going to distribute that 18, and that would be wrong. Remember your order of operations. Please excuse my dear Aunt Sally. Please P parentheses. Next one, exponents. You aren't going to get rid of those there's nothing to do inside the parentheses, so forget about the parentheses. Don't forget about the parentheses, but there's nothing to work inside the parentheses. Exponents. Exponents come before multiplication. So you can't distribute that 18 until you raised 2x plus 5 to the 8th power. None of us are going to raise 2x plus 5 to the 8th power, so that 18 cannot distribute. Order of operations, I've got to clear that exponent before I can do the multiplication. Okay, next one. H of x equals sine 3x. So again, my inside function is 3x. My outside is the sine function. So I start on the outside. The derivative sine is cosine. And I'll go ahead and use parentheses. And then I'll pause for a moment. So there's derivative outside. Then the rest of the words plug in plane inside. And so that means what goes on the inside is 3x. And immediately we notice my angle did not change. My argument does not change. Then the rest of the chain rule times the derivative of the inside. And again, that's a step you don't have to show. Well, the derivative of the inside, derivative of 3x is 3. And then all I can do to simplify this guy is move that 3 to the front, because it looks prettier there. But again, notice original angle 3, original argument 3, argument in the answer 3. The arguments of your trig functions are not going to change unless you did trigonometry to them, not calculus, not algebra. Now this sort of problem where I have mx or even mx plus b in my trig functions, that's going to come up over and over and over again. And you can do it with a chain rule each and every time, but we want to try to get a little more sophisticated with our work as we go on. So it will be perfectly acceptable just to learn that when your argument here is linear, mx, and even if it was mx plus b, linear mx plus b, that when your argument is linear, the effect of that slope, m, is going to be to multiply it by it every time. So derivative of sine mx will be m cosine mx. The derivative of cosine mx will be negative, because the derivative of cosine is negative sine, negative m sine mx. Derivative of tangent, m secant squared mx. Derivative of cotangent mx, negative m cosecant squared mx. Derivative of secant mx, m secant mx tangent mx. And cosecant mx, negative m cosecant mx cotangent mx. So the derivative of the trig function, we should all have those memorized, those are the same. And so then the effect of that m each and every time is just to multiply by it. Now, to remember it, you need to do a chain rule every time, do the chain rule. But as we get more sophisticated, it is permissible just to remember, oh, because of the chain rule, I know the effect of that m is going to be to multiply by it. And so I will accept answers where people just remember, oh, the chain rule is going to tell me I just need to multiply by that 3. And let's end the first lecture there.